Jai Hind and very good morning. So, my name is Dr. Tarun Bhardwaj. So, let us start with this lecture number 2 for this additive manufacturing module. So, this lecture 2 will basically consist of the what is the introduction we have means studied जितना हम लोगों ने पढ़ा और whatever is left that is basically related to the what is the distinction between the additive manufacturing and the CNC machining, and what are the different kind of the types, what are the different types of the additive manufacturing. So, we will just discuss in this lecture number 2. So, this is the outline, means the distinction between the AM and the CNC machining and the few classification of the additive manufacturing, just like the wet photopolymerization, stereolithography, material jetting, binder jetting, material extrusion, sheet lamination, powder bed and the die attach deposition. So, first of all, let us start with this distinction between the AM and the CNC machining. So, as you can see over here for the distinction means how additive manufacturing is different from the CNC machining. कैसे additive manufacturing CNC machining से अलग है, you can just see in this diagram that view in the first diagram you can just see over here in this number A that this is basically related to your CNC machining, that you are having material that is being cast, this is basically the casted material. तो करते क्या है दैट आप इसको मैन्युफैक्चरिंग सब्ट्रैक्टिव मैन्युफैक्चरिंग के पास लेके जाते हैं, मीन्स यू जस्ट टेक योर मटेरियल टू दी CNC मशीनिंग और देन यू यूज टू क्रिएट एनी ऑब्जेक्ट 3D ऑब्जेक्ट. ओके, एंड दिस इज द मटेरियल वेस्टेज, जिसकी जैसे कि मैं बात बताई आपको दैट इन द एडवांटेज इज दैट द वेस्टेज इज वेरी हाई in the CNC machining if we just compare with the additive manufacturing technology. Okay, and if we just see this additive manufacturing technology, then we are having the material either in the form of powder or in the form of wire. Then if you just take this material into the additive manufacturing, and this additive manufacturing is basically creating an object in a layer by layer fashion. So, the material that you can just see that the 3D object and this is your waste. So, you can just compare that you are having the 3D object with that much of the waste in the CNC machining, and if you just compare with the additive manufacturing, the waste is very low. So, this is basically showing you a whole picture about the that how additive manufacturing is different from the CNC machining. Now, you can also just see over here in these videos that how basically the CNC and the additive manufacturing works. So, this in the on the left side you can just see that this is basically the CNC machining and this is basically the additive manufacturing. Okay. Now, on we will just see that how they are just different on the different basis. As you can see, the first one is on the basis of the material, is how additive manufacturing and the CNC both are different if we just take material as a base. Okay. So, AM technology was originally developed around the polymeric materials, waxes and the paper laminates. As I have told you in the history that first of all we just originate means this additive manufacturing will originate for the first of all the resins, then for the polymers, then after that for the papers, then later it will be also developed for the composites and the materials and the ceramics. Okay. And if we just talk about the CNC machining, so CNC machining can be used for the soft materials like the MDF, that is the medium density fiber boards, and the machinable forms, machinable waxes or even some polymers, okay, and the metals also. So, CNC machining is basically be used only for the soft material over here, but if you just talk about this additive manufacturing, you are covering all the ranges of that material over here in the additive manufacturing. So, this is the basic difference between these both the techniques. Okay. The use of the CNC to shape the softer material is focused on preparing these materials parts for use in the multi-stage processing like casting. Means suppose if you have to create any object or any 3D model. So, what you used to do, first of all you used to have the casted part with you, then after that you used to machine that product. Okay. So, there are the number of the stages you have over here in the CNC machining, but when we just talk about the additive manufacturing, you are having only a single stage over there. But in AM part in constant may have a very wide and the anisotropy, that is because of the basically the development of your product, okay, and that is basically due to the process parameters that the additive manufacturing have, because these anisotropy is basically due to the you can say the thermal gradient that is basically over there in when you are just creating the object. जब आप एक object को create करते हैं तो you will just see that the first layer of the any product, suppose this is the first layer of any product, So you will just see that this first layer will always get the heat. Suppose this is your heat source, suppose a laser. So what happen actually, that this laser source will also heat up this first layer again and again. You are creating 100 of the layer over here, but what actually happen, this first layer will get the heat again and again. So due to the thermal gradient and the thermal gradient of the room temperature and this laser temperature is very high, and due to that thermal gradient we are having the anisotropy in the part, but in the CNC part that are more homogeneous and the predictable in the quality. So this is also a challenge in the additive manufacturing if we just talk about on the basis of material. Okay. Now if we just compare on the basis of the speed, so high speed CNC machining can generally remove the material much faster than the AM machines. It means if suppose we have to create the any shape, okay, so CNC will take a very less time than when we just compared with the additive manufacturing. But if we just compare as a whole process, means if we are just comparing the whole as a stage, so you will just see that a product will also take a time to cast and then it will come to the machining. Means if you are just comparing the whole time of the whole production time of that particular 3D object, you will just see that it will take more time than the additive manufacturing. But if you just compare with the process to process, additive manufacturing is a slow process in compared to the CNC process. Okay. So speed thus therefore be considered in terms of whole process, okay, rather than the physical interaction of the part material. Because CNC machine require considerable setup, process planning, particularly as part become more complex in their geometry. If the means the part is very complex, if the part is very means suppose somebody required the customization in the part, so that CNC machine required a considerable setup for that. ओके मतलब उसका आपको पूरा फिक्सचर्स डिज़ाइन करने पड़ेंगे. ओके यू हैव टू डिज़ाइन के कैसा टूल वहाँ पे मूव करे, तो यू हैव टू डिज़ाइन एवरीथिंग इन दैट पर्टिकुलर सीएनसी मशीनिंग. आपको वहाँ पे पूरा प्रोसेस जो है वो उसको डिज़ाइन करना पड़ेगा, देन यू जस्ट क्रिएट योर 3D ऑब्जेक्ट. बट यहाँ पे एडिटिव मैन्युफैक्चरिंग में ऐसा नहीं है. यू हैव इफ़ यू हैव अ 3D मॉडल विद यू, then you can just directly print that on the 3D machines. Now on the basis of speed, if we just see that CNC is likely to be a multi-stage manufacturing process that requiring a reposition or the relocation of the part with one machine or the use of more than one machine. Means if you are having a very high complex part, so it may be possible that you just required a number of machines over there. Okay, so but in the additive manufacturing it is not like that. You have to go for any product in a single stage, and if we just taking in the terms of time, then to make that part in a AM machine it may take only a few hours for that. But if you just compared it as a whole process, then you just see that for doing that, means for machining that particular product, what actually happens that you have to create some machining, means you have to create the milling on the one CNC machine and you have to go for the turning on the another CNC machine. So that will take your time. Okay, but in AM machines you have to do everything on that particular machine. You are creating a particular whole object on that particular machine. So that's on that basis, the if we just taken the speed, so speed is very high for this additive manufacturing process. Now on the basis of complexity, as I am talking about complexity again and again, जैसे मैं बार बोल रहा हूँ कि complexity parts के लिए, तो additive manufacturing is very useful for this complexity part, for the complex part and the customized part. Okay, so if CNC being used to create a part directly in a single piece, then there are some geometric features that cannot be fabricated. अगर हम लोग बात करें CNC मशीनिंग से, बहुत ही अगर इस टाइप के कॉम्प्लेक्स पार्ट अगर हमारे पास हैं, अगर इस टाइप के अगर मैं पार्ट बोलूँ कि CNC मशीन से करने हैं, तो दैट इज़ वेरी वेरी डिफिकल्ट, और it you can say कि it is not possible by this CNC machining to create such kind of the part. But additive manufacturing say these parts are very easy to create. Okay, so machining tool must be carried in a spindle. There may be a certain accessibility constraint or the classes preventing the tool from being located from the machine surface of a part. तो that these are basically the constraint of the CNC machining, जहाँ पे कि additive manufacturing का advantage है. Okay. Now this is basically the example that is showing you that अगर हम लोगों को एक बोतल में एक शिप बनाना पड़ जाए, ठीक है, you can see that a bottle is having a ship. अगर ये बोला जाए कि CNC मशीनिंग से इसको क्रिएट करना है, so it is very difficult to create by using any CNC machining or any other manufacturing process. Okay, but by using the additive manufacturing process, you can just easily create such kind of the parts very in a single stage. Okay, so this is basically the you can say the advantage, or you can say the ये इसका बहुत बड़ा फ़ायदा है एडिटिव मैन्युफैक्चरिंग का, दैट कि आप इस पे जो आप देख सकते हैं, जो आप सोच सकते हैं, वो चाहे वो कितना भी कॉम्प्लेक्स पार्ट हो, आप उसको यहाँ पे बना सकते हैं, आप उसका प्रोडक्शन कर सकते हैं. ओके, नाउ if we just talk about the accuracy, on the basis of accuracy, so AM machine generally operate with a resolution of few tenths of the microns. Okay, and it is common for the AM machine to also have the variable resolution along the different orthogonal axis. बेसिकली हम लोग इसमें वर्टिकल एक्सिस जो होती है हमारी, उसको हम लोग जो बेसिकली इसको हम लोग लेयर थिकनेस नाम देते हैं, एंड दिस वुड बी द लोअर रिजोल्यूशन दैट इज कंपेयर्ड विद द टू एक्सिस इन द बिल्ड प्लेन. अगर हम लोग तीनों प्लेन की बात करें तो तीनों प्लेन में जो हमारी वर्टिकल एक्सिस है वो ही बेसिकली इसका रिजोल्यूशन सेट करती है. सो लेट्स टेक एन एग्जांपल फॉर दिस, दैट सपोज वी हैव टू क्रिएट वन ऑब्जेक्ट लाइक दिस. ओके, suppose we have to create an object like this. So when you used to take a very high layer thickness, if you used to create a very high thickness, then what actually happen over here, that this will this when you used to create a very high layer thickness, so when you just see that the steering is very high for that particular product, means the layer thickness, when we just talk about the layer thickness, that staircasing, the stair are very high for that, and when we talk about the lower layer thickness, the steerings are very less. So what actually happen, that accuracy for the lower layer thickness is very high than the if we just talk about the high layer thickness. Okay, now the resolution of the galvanometer would determine the overall dimension of the part builds, while the diameter of the laser beam would determine the minimum wall thickness. Okay, so these are basically the components that are basically deciding, means how the part is basically being accurate or not. The accuracy of CNC machining is mainly determined by a similar positioning resolution along the all three orthogonal axes and by the diameter of the rotating cutting tool. Means if we just talk about the CNC machining, so over here हमारे पास जो होता है यहाँ पे, आप इसका जो बेसिकली जो एक्यूरेसी है वो आपके टूल के डायमीटर पे डिपेंड करेगी, ठीक है, या फिर टूल की थिकनेस के ऊपर डिपेंड करेगी. बट यहाँ पे अगर हम लोग बात करें एडिटिव मैन्युफैक्चरिंग की, तो जो उसकी एक्यूरेसी है वो आपकी डिपेंड करती है ऑन द बेसिस ऑफ दिस थिकनेस. ओके, नाउ इफ यू जस्ट टॉक अबाउट दी ऑन द बेसिस ऑफ ज्योमेट्री, इफ यू जस्ट डिस्टिंग्विश दैम ऑन द बेसिस ऑफ ज्योमेट्री, अगर हम लोग इसको ज्योमेट्री के बेसिस पे डिस्टिंग्विश करते हैं, सो एएम मशीन एसेंशियली ब्रेक अप अ कॉम्प्लेक्स 3D प्रॉब्लम इनटू अ सीरीज ऑफ सिंपल 2D क्रॉस सेक्शन विद अ नॉर्मल थिकनेस. मतलब अगर आपके पास एक पूरा 3 डायमेंशनल कोई प्रोडक्ट है, तो ये पूरे 3 डायमेंशनल प्रोडक्ट को एक 2D थिकनेस बेसिकली 2 डायमेंशनल प्रोडक्ट्स में डिवाइड कर देता है, स्लाइसेस, बेसिकली ये आपको स्लाइसेस में कन्वर्ट कर देता है, ठीक है. एंड देन कनेक्शन ऑफ द सर्फेसेस इन 3D इज रिमूव्ड एंड द कंटिन्यूटी इज डिटरमाइंड बाय हाउ क्लोज द प्रॉक्सिमिटी ऑफ वन क्रॉस सेक्शन इज विद द अनदर. सो आपका जो कनेक्शन है एक लेयर से दूसरे लेयर के बीच में, वो बेसिकली आपका यहाँ पे भी एक्यूरेसी बेसिकली यहाँ पे शो करता है इन द एडिटिव मैन्युफैक्चरिंग. ओके, बट इट इज वेरी डिफिकल्ट इन CNC दैट मशीनिंग ऑफ अ सरफेस मस्ट नॉर्मली बी जनरेटेड इन द 3D स्पेस. ओके, तो CNC मशीनिंग की अगर मैं बात करूँ, तो CNC मशीनिंग में अगर आपके पास ऐसे कोई ऑब्जेक्ट है जिनको हम लोगों को 3 डायमेंशनली बेसिकली मशीन करना है, तो इट इज़ वेरी क्वाइट डिफिकल्ट in the CNC machining to machine such kind of the surface. Okay, but it is quite easy in the additive manufacturing. Now with the simple geometry like this cylinder, cuboids, cones, है ना, these are basically a very simple geometries, so they are very relatively easy process defining by joining the points along a path. So these points being quite far apart and the tool orientation being fixed. तो आप यहाँ पे अपने टूल को फिक्स करके और एक पॉइंट से दूसरे पॉइंट पर ले जा सकते हैं. बट अगर सपोज आपका कोई ऑब्जेक्ट की जो बेसिकली जो डायमेंशन है कुछ इस टाइप की है, ओके, अगर आपका कुछ प्रोडक्ट इस टाइप का है, तो इट इज़ वेरी डिफिकल्ट इन द CNC मशीनिंग के इस पॉइंट से यहाँ पे आए, फिर यहाँ पे आए, फिर यहाँ पे आए, तो बहुत डिफिकल्ट हो जाता है CNC मशीनिंग के टूल पाथ को बेसिकली कंट्रोल करना. तो इन केसेस ऑफ द फ्री फॉर्म सर्फेसेज दीज पॉइंट्स कैन बी वेरी क्लोज टू ईच अदर. कभी कभी ऐसे कोई फ्री फॉर्म अगर हमारे कुछ सर्फेसेज है, तो उनके जो पॉइंट्स होते हैं वो बहुत ही आसपास बेसिकली होते हैं, तो वहाँ पे आपको कंट्रोल करना इट इज़ वेरी क्वाइट डिफिकल्ट इन द CNC मशीनिंग. ओके, तो सच ज्योमेट्री कैन बी एक्सट्रीमली डिफिकल्ट टू प्रोड्यूस विद द CNC इवन विद द 5 axis कंट्रोल और ग्रेटर इन द CNC. ओके, Now, if we just talk about on the basis of the geometry, so you can just see in this geometry that it is very difficult to produce with CNC even with the 5-axis control or greater. As you can see in this diagram that the cavity here may be too deep to machine. So it is quite difficult for a tool to go over there and to machine that particular surface. And if we just talk about over here, अगर हम लोग यहाँ की बात करें तो sharp internal features cannot be machined without a tool radius. आप यहाँ पे देख सकते हैं जो हमारे कप का बेसिकली जो पकड़ने का है, ठीक है, तो दैट इज़ वेरी डिफिकल्ट फॉर द CNC मशीन, क्योंकि यहाँ पे आप देख सकते हैं कि दैट इट इज़ वेरी अ शार्प फीचर ओवर हेयर. ओके, एकदम से शार्प चेंजेस आया है. ओके, नाउ बेसिस कैन नॉट बी मशीन सिंस द मशीन मस्ट होल्ड यूजिंग अ फिक्सचर. आपको जब भी आप CNC की बात कर रहे हैं तो आपको एक फिक्सचर चाहिए होता है उसको पकड़ने के लिए. Okay, so that is very difficult for the CNC machine. Now the undercut here cannot be performed without more than 3-axis machining. Okay, so it is not done by the, आप इसको किसी ट्रेडिशनल मशीनिंग की प्रोसेस से नहीं कर सकते हैं. Okay, so basically the undercuts, enclosures, sharp internal corners, okay, and the other features can all fail if these features are beyond a certain limit. So that is basically showing you that CNC is having some limitations with it. Okay, CNC is a very fast process, but it is having some limitations with it. If just talk about the customization and if we just talk about the complexity of the product. Okay, but if we just talk about the additive manufacturing, it is a slow process. And if we just compare it with the process to process, but it is a very you can say advantages in terms of the complexity and the customization. Now, if you just compare it on the basis of the programming, so the program sequence for a CNC machine can be very complex, include the tool selection, machine speed setting, approach position and angle, etc. Okay, so AM machine have an option that must be selected, but the range, complexity and the implications surrounding their choice are minimal in comparison. So this is basically the difference between if we just take on the basis of the programming. Now, the worst that is basically happen in the most AM machine is that the part will not be built very well in the programming is not done properly. Means अगर आपने कोई प्रोग्रामिंग नहीं करी, अगर कुछ गलत कर दिया है इस प्रोग्रामिंग में, तो होता क्या है कि आपका ज़्यादा क्या होगा, आपका पार्ट नहीं बनेगा मैक्सिमम से मैक्सिमम. बट इफ़ यू जस्ट टॉक अबाउट द CNC मशीनिंग, आपका अगर आपने कोई गलत प्रोग्रामिंग कर दी है, ठीक है, आपने अगर उसके जो पॉइंट्स जो प्रॉपर्ली डिफाइन नहीं करे हैं या G कोड्स और M कोड्स प्रॉपर्ली डिफाइन नहीं करे हैं, तो होता क्या है दैट इनकरेक्ट प्रोग्रामिंग ऑफ द CNC मशीन could result in the severe damage to the machine and may even a safety risk. तो जो बंदा उसको चला रहा है उसके लिए it is very you can say the tool can damage that particular man. Okay, so that is basically the safety consideration that we have to take in the CNC machines. Okay, and अगर additive की बात करें तो इस टाइप का हमारा कोई ऐसा कोई अगर प्रोग्रामिंग गलती कर दी है तो वो रुक जाएगा. Okay, so this is basically the whole about the distinction between AM and CNC machining. Okay, now so if you just talk about some classification of the this additive manufacturing process, so we are having a different means the classification over here in this additive manufacturing process. Okay, so the first one that I have told in the history that कि जो पहला जो process basically हम लोगों ने बनाया that is the wet photopolymerization और stereolithography, जो सबसे पहले basically originate हुआ. Okay, so wet photopolymerization uses a wet of liquid photopolymer resin out of which the model is constructed layer by layer. You can just see in this diagram, आप इस वीडियो में भी देख सकते हैं कि कैसे आपका बेसिकली जो लेज़र है वो आ रही है, एंड दैट इज़ यूज टू क्योर दैट लिक्विड, एंड दैट लिक्विड इज़ बेसिकली कन्वर्टेड और दैट इज़ बेसिकली सॉलिडिफाइड, एंड दैट सॉलिडिफाइड जो पार्ट है वो फिर नीचे चला जाता है, फिर उसके ऊपर एक लिक्विड आ जाता है और फिर उस लिक्विड को हम लोग क्योर करते हैं, दैन दैट इज़ कन्वर्टेड इनटू सॉलिड फॉर्म, फिर वो नीचे जाता है. तो ऐसे पूरा एक 3D कंपोनेंट आपका बनता है. एंड दिस UV लाइट इज़ यूज टू क्योर or harden the resin where required. Okay, so whilst a platform moves object being made downward after each layer is cured. जैसे ही आपकी एक layer बन जाती है. So let's start with the classification of this additive manufacturing process. As I told you that there are the different kind of the process we have, the wet photopolymerization, we have stereolithography, and we have the powder bed fusion mechanism we have, and the direct energy deposition process we have. So they are the different kind of the process we have. So let us start with this wet photopolymerization or the stereolithography, because this process is being firstly developed by the this Kodama, Dr. Kodama. So let us take that how basically the process basically happen, कैसे basically इस process में क्या होता है, because this process is basically being developed for the resins first of all. No? So the wet photopolymerization use the wet of liquid photopolymer resin, out of which the model is constructed layer by layer. As you can see over here in this diagram also, that how the laser is coming and it is basically used to cure that particular liquid into the solid form. मतलब आपने एक लेजर डाली, that is वो क्योर कर रही है आपके लिक्विड रेजिन को, और क्योर करने के बाद दैट जो लिक्विड रेजिन है वो कन्वर्ट हो जाता है into the solid form. Okay, as you can see in this video also, and that UV light is used to cure or harden the resin where required, whilst a platform moves the object being made downward after each layer is cured. तो आपका जो wet है वो बार बार डाउनवर्ड हो जाता है, ठीक है. तो दैट्स वाई द नेम इज गिवन ओवर हियर द वेट फोटोपोलिमराइजेशन. ओके, सो what actually happened in this wet photopolymerization? In this case the support structure will often need to be added. हम लोग को यहाँ पे support structures भी देनी पड़ती हैं. Resins are cured using a process of photopolymerization of a UV light, where the light is directly across the surface of the resin with the use of motor controlled mirrors. तो यहाँ पे आपने जैसे पहले भी वीडियो में देखा है दैट यू आर हैविंग अ मिरर्स ओवर देयर. तो जो मिरर्स हैं दैट इज बेसिकली यूज टू गवर्न दैट हाउ दे यूज टू मूव दैट लेजर और द अल्ट्रावायलेट रेज to cure that particular liquid or that particular liquid resin into so that they can be converted into the solidified form. Where the resin comes in contact with the light, it cures or harden. As the process uses the liquid to form the object, so there is no structural support from the material during the build phase, unlike the powder based method where the support is given from the unbound material. तो इस केस में क्या होता है कि अगर आपको सपोज यू हैव टू गिवन सम सपोर्ट मटेरियल, अगर आपको सपोर्ट मटेरियल देना है तो आपका जो मटेरियल है दैट इज सेम ऑफ दी योर जो भी आपको 3D कंपोनेंट बनाना है. बट अगर हम लोग बात करें अपने मेटलिक 3D प्रिंटर की या फिर FDM की बात करें, फ्यूज डिपोजिशन मॉडलिंग की बात करें, तो वहाँ पे आपका जो सपोर्ट मटेरियल है वो किसी अनबाउंड मटेरियल के साथ हम लोग उसको सपोर्ट मटेरियल देते हैं, सो दैट वी कैन मशीन, हम लोग उसको मशीन करके बाद में निकाल सकें. ओके, सो इट इज़ नॉट इन दी वेट फोटोपोलाइजेशन और द स्टीरियोलिथोग्राफी. So this is basically the step by step process कैसे होता है. So the build platform is lowered on the top of the resin, wet downward by the layer thickness, and the UV light cure the resin layer by layer, and the platform continues to move downward and additional layer are built on the top of the previous one. मतलब आपके पास एक लेयर बन गई है, देन वो आपने क्योर करी है, उसको सॉलिडिफाई फॉर्म में कन्वर्ट कर लिया है, उसके बाद फिर आपका वेट नीचे गया, फिर उसके पास दूसरी लेयर बनी, और ऐसे लेयर बाय लेयर आप पूरा एक 3D कंपोनेंट बना ले रहे हैं. तो सम मशीन्स यूज अ ब्लेड विच मूव्स बिटवीन अ लेयर इन ऑर्डर टू प्रोवाइड अ स्मूथ रेजिन. क्योंकि आपको एक लेयर चाहिए तो वो जो लेयर है उसकी अनइवन थिकनेस ना हो, दैट्स व्हाई वी आर यूजिंग सम ब्लेड. हम लोग को एक ब्लेड वहाँ पे यूज करना पड़ता है, और समटाइम वी आर ऑल्सो यूजिंग अ रोलर ओवर देयर, ताकि वो एक हमें स्मूथ थिकनेस मिल पाए. ओके, नाउ आफ्टर कंप्लीशन द वेट इज ड्रेन्ड ऑफ द रेजिन एंड द ऑब्जेक्ट विल रिमूव फ्रॉम इट. Okay, so this is the whole process of the photopolymerization. Okay, now if we just talk about the material jetting, अगर हम लोग material jetting की बात करें तो this is also a 3D printing technology, second 3D printing technology. So the material jetting creates the object in a similar method to the 2-dimensional inkjet printer. जैसा कि हम लोग आपके प्रिंटर्स होते हैं जहाँ पे आप लोगों ने देखा होगा कि वो भी बेसिकली क्या करते हैं, दैट यू हैव टू क्रिएट द, आपको जब कोई सपोज यू हैव टू प्रिंट योर मीन्स अगर कोई पेपर प्रिंट करना है तो उसमें होता क्या है कि आपका जो प्रिंटर है दैट इज टू इंजेक्ट द इंक ऑन दैट पर्टिकुलर पेपर. ओके, सो सेम ओवर हेयर, जैसे आपको 3D कंपोनेंट बनाना है तो यहाँ पे भी आप बेसिकली क्या कर रहे हैं, इंजेक्ट कर रहे हैं मटेरियल को, जेट कर रहे हैं ऑन दी प्लेटफॉर्म, ऑन अ प्लेटफॉर्म और सम यू कैन से अ बेस मटेरियल, जिस पे भी आपको बेसिकली 3D कंपोनेंट को बनाना है. ओके, so material jetting creates the object in a similar method to the 2-dimensional inkjet printer, and the material is jetted on a build platform using either a continuous or the DOD approach, means the demand on drop approach, drop on demand approach. मतलब जहाँ पे आपको बेसिकली ड्रॉप की जरूरत है वहाँ पे आप उसको बेसिकली जेट को स्प्रे करा रहे हैं. ओके, नाउ material is jetted onto the build surface on a platform. When it solidifies, the model is built layer by layer. As you can see over here that there is a workpiece और आपका जो liquid जो basically आपने liquid state में जो material को भरा हुआ है, this is basically your you can say the printed head over here. तो ये print head आपका जहाँ पे भी आपको requirement है वहाँ पे इसको spray करेगा और spray करने के बाद that liquid is basically converted into solid जो कि आपकी एक layer बनाएगा. Then after that in the similar fashion जैसे कि सारी टेक्नोलॉजी हैं कि एक लेयर के ऊपर आपकी दूसरी लेयर के ऊपर आपकी तीसरी लेयर, देन आफ्टर द नंबर ऑफ द लेयर्स जितनी भी जरूरत है फॉर दैट पर्टिकुलर 3D कंपोनेंट इट इज यूज्ड टू क्रिएट योर 3D ऑब्जेक्ट. ओके, नाउ material is deposited from a nozzle which moves horizontally across the build platform. Okay, and the machines vary in complexity and in their methods of controlling the deposition of the material, and the material layers are then cured or hardened the UV light. As the material must be deposited in the drops, the number of the materials available to use is limited. Okay, because यहाँ पे हम लोगों को ड्रॉप फॉर्म में बेसिकली मटेरियल को जेट करते हैं हम लोग, तो इसका बेसिकली ये है कि आपकी जो थोड़ी कंस्टेंट हो जाती है मटेरियल के लिए यहाँ पे. तो पॉलीमर एंड वैक्सेस आर सुटेबल एंड कॉमनली यूज मटेरियल ड्यू टू देयर विस्कस नेचर एंड एबिलिटी टू फॉर्म द ड्रॉप्स. ओके, so what is basically the procedure? That print head is positioned over the build platform, droplets of the material deposit from the print head on through the surface, and the droplets of material it basically solidifies and make up the first layer. Then further layers are built up as before on the top of the previous, and the layers are allowed to cool and harden by the UV lights. Post processing include removal of the support material. So this is basically the whole process of material jetting. So thank you so much for this. We will just continue again for all other processes. So thank you.